Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello everyone. It's my pleasure to welcome all senior 6 students to join me in this lesson. Of course, my name is John. I'll be working for mathematics, yes, in Unit 4 of integration. We have been talking about integration of trigonometric functions, part 1, because there are very many kinds of trigonometric, of integral involving trigonometric functions. But remember that we had integral of this form, square root of 1 plus or minus cosine x dx, integral of square root of 1 plus or minus sine x dx, integral of 1 divided by 1 plus or minus cosine x dx, and integral of 1 divided by 1 plus or minus sine x dx. This was our first lesson on integration involving trigonometric function. Today, we look at another kind of integral involving trigonometric function, but before that, let us have an exercise, an activity on these kind of integrals, right? Where you have to evaluate these two integrals. Integral of square root of 1 minus cosine x dx and the integral of 5 divided by 1 minus cosine x dx. Please, you can take just a minute to evaluate those integrals, then we shall continue with another kind of integration of trigonometric functions. So I hope you are done. Let us make the correction on chalkboard, right? Follow on chalkboard. You know, when we deal with this kind of integral, we have to think about double angles in trigonometry, or half angle, I'm sorry. So it means that when you have cosine x, this is equal to cosine x divided by 2 plus x divided by 2, half angle, and you will get cosine squared x divided by 2 minus sine squared x divided by 2. And you know also that 1 is equal to cosine squared x divided by 2 plus sine squared of x divided by 2. So when you take 1 minus cosine x, you get cosine squared of x divided by 2 plus sine squared x divided by 2, then minus cosine of x, this is cosine squared of x divided by 2, then minus sine squared of x divided by 2. So removing bracket, I'll be having cosine squared of x divided by 2 plus sine squared of x divided by 2 minus cosine squared of x divided by 2. Negative, negative, it will be positive. That is sine squared of x divided by 2. So this cosine squared of x divided by 2 and this one are vanishing. I remain with 2. 1 minus cosine x is equal to 2 sine squared of x divided by by 2. Then square root of 1 minus cosine of x, it will be square root of 2 sinusoid of x divided by 2, which is equal to square root of 2 times sine of x divided by 2. Means that our integral of square root of 1 minus cosine of x dx is equal to square root of 2 integral of sine of x divided by 2 dx. Remember, when you have integral of sine a x dx, this is equal to minus 1 over a cosine ax, then plus c. For me, I have x divided by 2, means that a is a half. So this is equal to square root of 2 divided by, that is 2, square root of 2, minus cosine of x divided by 2, plus c, means that you have a negative 2, square root of 2, cosine of x divided by 2, plus c. That is the answer for the first integral. The following, we have to conjugate the denominator. So integral of 5 divided by 1 minus cosine x dx is equal to 5 times integral of 1 divided by 1 minus cosine x dx. Hope you are together. Oh, thank you. So this is, because I have to conjugate, it will be 5 integral of 1 plus cosine x divided by 1 minus cosine x times 1 plus cosine x dx. And I get 5 integral of 1 divided by 1 minus cosine squared of x dx. 1 minus cosine squared of x is sine squared of x. Means that I have a 5 divided by 1. Oh, sorry, this is 1 plus cosine x plus cosine of x divided by sine squared x dx. This is 5 integral of 1 over sine squared x plus cosine of x divided by sine squared x dx. You know 1 divided by sine x is cosec x. So it means that I have 5 integral of cosec squared of x. Cosine divided by sine x is cotangent x, and the 1 divided by sine x is cosec of x dx. And this will be equal to 5 times integral of cosec squared of x is minus cotan of x. So minus cotangent of x. Integral of cotangent of x times cosecant of x is minus cosec of x, then plus c. So the answer is minus 5 times cotangent of x plus cosec of x, then plus c. We are done. So I hope this was a kind of a revision of integral trigonometric function of this kind, involving square root of 1 plus or minus cosine x, or 1 plus or minus sine squared of x, sine x, or 1 divided by 1 plus or minus cosine x, and 1 divided by 1 plus or minus sine x. So this time, we are going to continue with integral of trigonometric function. So this would be part 2, right? And for that case, we have integral of this kind, integration of the form integral of a times cosine x plus b sine x divided by c cosine x plus d sine x dx, and integral of a cosine x plus b sine x plus c divided by d cosine x plus e sine x plus f dx. Of course, a, b, c, d, e, and f, these are real numbers. And all these real numbers are not zero at the same time. It can happen, a can be zero, but b is different from zero. B can be zero, a is different from zero. C can be zero, d is not zero, and so on. Even here, b can be zero, you have a cosine x plus c, and maybe f can be zero, you remain with d cosine x plus e sine x, and so on. Okay? So how to integrate, how to evaluate this kind of integral, where we have a linear polynomial, trigonometric polynomial on numerator and denominator. So the method is very simple. Follow how we work. What we do, first of all, we take the numerator and we equate to, we have 2 constant a times the denominator then plus b times the derivative of the denominator. So this is divide the x of denominator. Means you take the denominator, you differentiate. You multiply by a constant b, of course, to be determined. So after you equate the coefficient of sine and cosine, the coefficient of sine x and cosine x to get the values of a and b. After getting the values of a and b, the integral becomes very simple. It becomes very simple. It is of this form: a plus b times derivative of the denominator divided by the denominator. Dx. Then the final answer, as this is a constant, it will be ax, as we have the integral, where the numerator is the derivative of denominator. You know, we had that kind of integral. It is somehow a standard integral. So that will be ln b times ln of denominator. Of course, you add the constant. That is the method. Then, to be very clear, let us explain through an example. Example. Integral of 26 sine x minus 13 cosine x divided by 4 sine x minus 4 sine x minus 7 cosine x dx. Please follow here on chalkboard. As the method is there, we are going to take the numerator, which is 26 sine x minus 13 cosine x, which is equal to a times the denominator. My denominator is 4 sine x minus 7 cosine of x, then plus b times the derivative of this denominator. So derivative of this denominator, you know it is 4 cosine of x. Derivative of cosine x is negative sine x. It means that with this negative sign, it will be 7 sine of x, like that. See that the derivative of denominator. Now, we are going to reduce my polynomial, means that the terms in sine will be together, and the term in cosine will be together. So this will be 4a sine of x minus 7a cosine of x plus 4b cosine of x, then plus 7b sine of x. Term in sine, I have a 4a plus 7b sine of x plus minus 7a plus 4b cosine of x. Of course, at the left-hand side, it is still 20c. 6 sine x minus 13 cosine of x. So means that the coefficient in sine must be the same, and the coefficient in cosine must be the same. It means 4a plus 7b is equal to 26, and then minus 7a plus 4b is equal to minus 13. Do you see? Is that difficult? Not at all. It's very simple. Now we are going to solve a system of linear equation in two unknown. The unknown are A and B. Even students from senior 2, senior 3 can solve easily this system. So let us multiply by, I want to eliminate A, so I can multiply by 7, and then multiply by 4. So I'll be having 28a plus 49b, which is equal to 182, and that will be minus 28a plus 16b, which is equal to 52, minus 52. Yeah. So the sum is at vanishing. This is 65. B, which is equal to 130, yes. So B is equal to, when divided by 65, it is 2. Getting the value of A, B, we can find the value of A easily. We know 4A plus 7B equals 26. Means that 4A plus 7 times it is 14 is 26. 4A is equal to 26 minus 14. 4A, this is 12. Means that A is equal to, we divide by 4, that is 3. We have the value of A, have the value of B. Okay? So we continue. Our numerator, it was 26 sine x minus 13 cosine of x. That is A. A is equal to 3 times the denominator, that is 4 sine x minus 7 cosine of x, then plus b, it is 2 times the derivative. Derivative is 4 cosine x plus 7 sine of x. So our integral, we can now work on this integral. Please, I give you 1 minute to write something on the method, especially. While I'm preparing the chalkboard, we can continue. But write this method in that example quickly. So back to our integral, we have integral of 26 sine x minus 13 cosine x divided by 4 sine x minus 7 cosine x dx. D is equal to integral of, I replace the numerator by its value. That is, a is equal to 3 times 4 sine x minus 7 cosine of x plus 2. B is equal to 2. Derivative of that, let me write derivative of 4 sine x minus 7 cosine of x divided by 4 sine x minus 7 cosine of x dx. So when you observe 4 sine x minus 7 cosine x and this one, they are the same, you can simplify. Means that I have integral of 3 plus 2 derivative of 4 sine x minus 7 cosine x divided by 4 sine x minus 7 cosine x dx. So it means that you have integral of 3 dx plus 2 integral of derivative of 4 sine x minus 7 cosine x divided by 4 sine x minus 7 cosine x dx. And we get 3x, because this is a constant, plus 2 is the numerator is the derivative of the denominator. That is ln of 4 sine x minus 7 cosine x plus c, which is not different from what you have here. Do you see? So the method is working for this kind of integral or this one. Hope you have understood the method. We can continue, maybe with another example. But before that, you can take a few minutes to write down this answer. Number 2, another example. You have integral of 5 cosine of x plus 6 divided by 2 cosine x plus sine x plus 6 dx plus 3 dx. As you see, this integral is not different from this one, even that one. Of course, there the term in the sign is not there. And you have the term independent. The method is the same. When you take 5 cosine x plus 0 sine of x, you will get a times 2 cos x plus sine x plus 3 plus b times minus 2 sine x plus cos x. When you equate, as we did before, you will get the value of a and the value of b. I'm going to give the value of a because it is simple to everybody. A will be 2 and b is equal to 1. So finally, when you solve, you are at this level, you will be having integral of 2 plus 1 derivative of 2 cosine of x plus sine x plus 3 divided by 2 cosine of x plus sine x plus 3 dx. And you get 2x plus ln of 2 cosine of x plus sine x plus 3, then plus c. We are done. So any kind of such integral will be evaluated following this method. I hope it is very simple. Thank you for your participation. Thank you for having me in this lesson. I hope to meet you next time. Stay enjoying mathematics. Bye-bye.